The goal of my presentation is really to describe maybe the long-term strategy we have at IPSL to tackle some constraint that has been raised by CVIP6 exercise in terms of compute and analytics purpose. And at IPSL, this is in charge of the Esprit platform. So Esprit is a platform at IPSL that gathers all the services for the IPSL research. It relies on 3 pillars, and one of them is my team at IPSL, and our mission is really to be at the pivotal position between the researchers on one side and the data on the other side, to accompany them from the data to the knowledge, which are very different in terms of analytic purposes. So basically, as you know, we can now summarize our mission into 1 or 4 words, so to say, so to be fair with the data, and also we have to be fair now with the environment for the research. So it's not only to be findable, accessible, interoperable, and reusable for the data, but we also need to be fair for the environment, the computing environment used by the researcher to reproduce the analysis. So I will be very quick on the description of the Esprit platform. So at the local level, this is a platform at IPSL focused on the access and distribution of the data for the research and the analysis. And it's really based on the non-demand data access from our researchers, from our community at IPSL. The platform gathers several kinds of data pools. For the first one, as you know, are the CMIP data. We also have regional data around the Codex projects. And we also replicate OpstormIPS data and the input dataset for the CMIP exercise. What is really interesting on the platform is that we also have some observations from ground-based experiments, satellites, reanalysis, which are the charge of another team in the Esprit platform. So we are really collaborating together to managing the different data pools and crossing the data for the scientists. And the last pillar of the platform is the hardware or the environment, the computing environment, which rely on 2 sites, geographical sites, one in Paris and the other one in the suburbs of Paris. So it's a really mutualized platform that aims to provide an optimal access to on the climate observations on one side and the model results on the other side. And we are putting those close together to heat the computing resources for the research analysis. So this federated infrastructure is in 2 sites with shared computing resources. So either you log on the one or the other side, you can both run different jobs on the same infrastructure with the same resources. I talked about data facilities, so we shared around 3 petabytes of data. And those data pools are remotely mounted on both sides to be completely transparent for the users. So we share the computation frameworks, and we also share the different data pools transparently for the users. And of course, we also implement services for our different scientific teams. So we have acquisition and archival. So you already know about this into the ES-ENES, that IPSL is replicating some other results or participating in some observation campaigns. But we also host ESGF nodes, as you know. And more aside on this, regarding all the civil society, we participate as much as we can to different climate services projects. So the most one you know is the Copernicus program, but we also have other initiatives at a more national level. So the next level of the Esprit platform is the Climairie France infrastructure. So Esprit is part of the Climairie France infrastructure, and in this infrastructure, we coordinate between the different French partners. So the CNRM, Fairfax, and all our APC center we use to realize the CMIPS exercise. And this is the schema I always use when I describe the Climairie France infrastructure. So in blue, on the right, on the left of the schema, you have the two sides of the Esprit platform. On the left side, you have the Paris site, and on the right side, you have the site in the suburb of Paris. And the two other polygons in the schema are both HPC centers. On the one, we only make production for CMIP6 exercise. On the other one, we make all replicating system from the other climate modeling groups. So I won't dive into the details of the schema here, but you just need to know that all those sites are linked into dedicated network architecture in order to avoid moving data across the sites, which take a lot of time, and in order to cross the data very easily and transparently for the users. So once you are logged into one of the blue sites on the Esprit platform, you can view all the data produced by the IPSL from one of the HPC center. And you can also see transparently next to the previous one, all the data replicated by the IPSL on the other HPC center. So it's really this network architecture that is important for us in order to avoid moving data and to heed the analytics environment on the platform directly. The next level is the IS-ENES-RI. So I will be very quick on this because we are here to discuss about this. So our first goal into IS-ENES is to really strengthening the infrastructure, especially through the ESGF operations. And so the last level is the ESGF1 international level, where we operate into the TMIP data node operation team, also in the ESGF governance, and we are the principal investigator for ESDoc documentation. So basically on this map, I can zoom the different levels. So you know the ESGF participants in the whole world, in the recent map I recently updated. Then you can focus on the Europe zone with the different IS-ENES partners, and in the France you can see the Climairie infrastructure, and then it's your focus in the Paris and the suburbs. You can see the Esprit platform in terms of ESGF nodes here, but it's really, it illustrates those different levels of the platform and its implications. Okay, so now why we built this platform and we interact in those terms with the others. So basically the first issue we have to deal with is the climate big data. So basically, especially with CMIP6, we see that we have very, very huge amount of data in terms of number of files, but also in terms of storage. And this is really a big constraint now and for the future, if we already think about the NIP7. So it becomes difficult to move the data. It becomes difficult to find the data early on the file systems. So we already need to think about this, and I will show you some proof of concept or strategy we are already thinking about at IPSL. We also have some lessons from the past and more from the users. When we distribute our data, or already from the researcher, when the researchers dive directly into the file system, we have some feedbacks from them. So they all observe some vocabulary discrepancies between the different nodes or between the different model results. There is some inhomogeneous indexes. We have constraints from the POSIX file systems. maybe that the main constraints we have now, so some scientific analyses are really difficult because NetCDF are difficult to subset, for instance, or interpolate depending on the different chunks on the POSIX system. So we have to explore other ways to store the data. And most of our users are also lost in the user interface and are very discouraged to discover the data. And had I just say at the beginning that there is such kind of reproducibility crisis in the research now, so not very high in the environmental sciences, but we have to keep in mind that now, for instance, when a scientist wants to publish some results, he have to deal with the data traceability, but he have also to deal with the environment he used to make his analysis, to make its graphs or different statistics. And this is maybe the main point raised with the last months, and especially for the next IPCC report, a lot of our scientists asking us to make some DOIs on the data, which is already solved with the PID system we have for semiphysics, but they also ask us to have a traceable environment to make the analysis. So now I will just address some ideas more than really tools already implemented at IPSL. So you have to keep in mind that since Sébastien Danville left the IPSL, I don't have all the time to implement such a thing, but we are already thinking about centralizing the Esprit platform around the analytics rather than the compute part especially. So one of the idea we have now is to improve or complete our analytic environment around a climate assessment framework. So it's an open source software we developed at the national level in France, but it's really open source, which is able to deal with the different DRS of the project, to share diagnostics between the different analyses. You can plug in your different script to subset, regrid, mean some ensembles and so on. So it's really useful for a basic research. So it gathers different diagnostic pre-computed into the code. We have feature plan for it. First is to improve the discovery on the file system through this tool, which is not really efficient. So we aim to implement the PySSV CV manager. So maybe you already heard me talking about PySSV manager, and we also talk about X-ray and Dask support instead of CDO operators. We are not sure how we can benefits of this, but I have in my mind that X-ray Dask can have very high potential even on POSIX systems. So we are discussing about this for this framework, analysis framework at IPSL. The next idea is to have in production a Kubernetes instance on one of the two blue sites in the schema before. First, to support Jupyter notebooks for training purposes and also for analysis traceability. So the goal here is really to be able to have a kind of container for an environment containerized for the scientist in order to make a DOI on it and to retrieve or share this environment for anyone who wants to redo the analysis. The other reason for deploying a Kubernetes instance is for the ESGF data node hosting. So it was the conclusion of the previous ENES workshop for ESGF architecture, which conclude to rely on Docker images for ESGF deployment. So it's a good opportunity here to have a Kubernetes instance at IPSL too. So, for instance, this is a kind of schema imagined by Sebastian some months ago. I will not dive into the detail too, but the idea is to have a data infrastructure relying on, so notebook services relying on the data infrastructure, and which is able to generate DOI for the analytic environment. And on the other side, you can generate DOI for the data use, making your paper, and providing with your paper all the DOI needed to redo the analysis. The next idea is to explore the object stores. So it's really general. We don't have direct projects. We are more listening what is done outside of the IPSL. So you already heard about the Google Cloud project that replicates some terabytes of Semip6 data. So we are really interested to this. Also in the Pangeo binders solutions, which can replace in some ways the Jupyter notebooks for some purposes. So this is another schema version, but I will skip it. Another idea we have is to work on a proof of concept of a front end or an index for a kind of climate dataset finder. So to tackle the issue that our users are lost into the user interface, the data reference syntax of our big projects, and to heed the way that discovers the data we have at IPSL first. So we imagine a kind of front end where the user only have one field to start asking some data, and then depending on what the user is writing, the front end is able to add some suggestions about variables, frequencies, and so on. So you don't need to know prior the DRS to make your research. And the last one is obviously the web processing service. We first deploy in the client. So that the WPS we are deploying into the climate services context for Copernicus in collaboration with the DKRZ and TIDA. I must admit that at IPSL our plan is really to have WPAs only for climate services purposes. I think that it's a very good tools to have pre-computed diagnostics for interpolation, for instance, of subsetting and so on. That is really that really answers to the need of climate services from outside of the research community. But when I talked about web processing services with the researchers, they really prefer to have their own made script or directly diving into some codes and don't want to click on different front ends to directly run some jobs somewhere they don't really know and so on. That's the feeling I have. So for the next years, I think I will keep web processing services more for climate services rather than for the research based. So for web processing services, we rely on the bird-out solution for the time being, provided by DKRZ. And the example in the Copernicus, we have a load balance web processing services, which is a very, very good initiative and promising. So that's all. Sorry, I was maybe quite long. So excuse me for this. Thank you.
So thank you